Well, hello, good morning. Thanks so much for joining me here in my shop. It's August 29th today, and today I'm excited because I feel very reassured that I'm going to fix that guy today. In fact, in just a few minutes. So just a recap of how I got here and what has happened that makes me think I can fix it now. And then we're going to get to it. So just a recap on the journey here. So this unit, while I was getting familiar with it, seemed to be working pretty good, largely working anyway. I left it on for a period of time, left my shop. When I returned to my shop, the output had disappeared. From that point forward, which was maybe 5-6 days ago, I kind of lost count, I had been pursuing what has happened to it. Oh, Peanut, really? Now? Already? That's my cat, in case you don't realize it. So I'm going to finish my little talk here and then deal with my cat. So I've been in here, I posted a number of videos of me, often starting with me saying I'm going to fix it, just like this one, except I'm going to do it this time. And then ending up in just confusion. And kind of no wonder I'm getting readings, 164 ohms, and there is no way you can explain 164 ohms, except I can't now. Well, I'm going to have to cut this short, or I'm going to disrespect my cat, which I do my best not to do, because he respects me, I respect him. I'm going to have to stop right at this point. So from here, I'm going to show you what the problem is. Come on, Peanut, let's go do what you want to do. What do you want to do? Peanut, what do you want to do? Okay. Okay, got my cat taken care of. So, just to review what was going on. So at this point, you'd expect to find some high resistance if you measured this relative to the chassis or ground. This is a ground line here. And I would get a test result here of 164 ohms. After a while, this became 172 ohms. Last night when I discovered the problem, it was 137 ohms. Not as stable as I thought. I thought the 164 was extremely stable, but it's not. And 100 high and low for this thing, and 164 ohms or whatever is just not explainable at all. Let's look at what happened here. Because it is explainable. It's just explainable in a way you would never imagine. So, this point here, let me just take this clip off. So this is the tube terminal coming out, and this is a terminal from up here bent back over, and the two of them have been joined with solder right here. Right below them is a resistor. You can see one lead here, and there's a resistor right underneath it, and the other lead is right in there. You can see one of the stripes on the resistor there. Those are in contact. So now I'm going to demonstrate the problem. Now we're going to find out if I'm really correct or not. Boy, you know, I'm actually shaking a little bit because it's truth or not truth. $148 ohms. Okay, I'm now going to pry apart the resistor and the part that's in contact with it, with this little guy here. This is what I did last night. I just touched it in here and went, look at that. Here we go. They're really pushed together here. I think I got to bend the resistor is what I need to do. Tell me I'm wrong. Don't tell me I'm wrong. Oh no. Wait one, pick a minute here. flooding. If you've stuck with me on this all the way through all these videos, well, thank you very much. Let's see if the payoff comes now. 149. There's no contact in here. Am I wrong? How come we saw a 0? Maybe because I did. Come on, man. Certainly when I flex this, something happens. Look at that, got it right down to 0 there. 149 again. What is going on in there? An egg in my face now already. Boy, I'm telling you, I'm absolutely convinced this is the problem here. The tube is not plugged in, by the way. Oh boy. Let's just try it again. Just touching the resistor here. Well, I think that was the sound of the resistor breaking right there, I think. What happened there? Son of a gun, it's not going away. So that resistor. Oh my gosh, I'm just, disappointment has returned big time. So now we have 149 ohms. Very stable. So the part we're looking at here, see how they've bent over this part here. These are two terminals bent together and soldered. This resistor is tucked underneath it. That's the resistor that's pushed right underneath. Not like they've shown it. Well, the way they've shown it, you get a wire short in there if you weren't careful. 100K. Let's see if it's 100K. Let's see about that. Here to here. It's 100K. They don't come much closer than that. So my theory was somehow this these terminals had somehow shorted into the body of the resistor and had obtained a resistance, this odd resistance that we're getting. And because it's halfway through a resistor. And now I'm explaining why I was wrong. What has happened? This guy is just driving me nuts. How come it's a 0 now? Okay, so now I've got my little screwdriver shoved in here and I'm able to put a lot of flexing force into the top part of the ink reductor here. Just watch the ohm meter. I can see the switch moving. Everything's moving. Nothing's happening whatsoever on that ohm meter. I can't see that this is going to be the source of the difficulty here. What I'm left with now is, what am I left with? So So just to review exactly where we're at, we're reading 152 ohms between the stator and ground. 152 ohms. Find this right. Get all turned around here. It's this way. For crying out loud, if it's not in the ink reductor, where is it? So I flexed the top part quite a bit, but for all I know I didn't flex the bottom part, and this has changed dramatically from time to time. It's 152 now. What is it that's changing that? Let's just check the meter here. Something funny in the switch. There's nothing to the switch. There's nothing I have done that has indicated it is the switch at all. Even switching in these coils doesn't do anything, which is the weirdest thing. How can that be? How can it be? How can it be? This resistance reading is coming from basically this band to the chassis. It's got all these wires going in here. When I rotate the switch and connect the wires to different things, nothing happens to that reading. It's thoroughly bizarre too. Well, maybe with 152 ohm short in there, if that's what it is. You can't see what's happening when you operate the switch. So you're switching in very but look like zero resistance coils. They're small coils. This one's got heavy wire on it, this one. Zero resistance is pretty realistic. Wow. Well, I think I have to separate. I think I have to, well, I have to take this wire. I've got to free the bands away from everything else. I've got to cut this wire here. That wire and one more wire. Two wires which I think I can reconnect. Those wires are coming to the top band, bottom band. All that's left is this resistor, 22K. If I remove that, the bands are free except for the 22K and the switch. Just by cutting two little wires. Well, it doesn't work now, so why would I hesitate? I'm sure I can reattach these wires, even though they'll be shortened up. There goes one. Nothing happened. There's only one left. Why does it look like there's two? Because I'm not seeing the actual wire here. Okay, we're going to go in for number 2. Trying to cut it so I have as much wire left as possible. To make the reconnection. Cut. Now what I think I'm reading is the resistance of only, oh, when did that happen? I thought I looked over and it was still shorted. Let's go on this band. Okay. until something happened there and I wasn't looking really. Well, you know what that tells me. I gotta get down the end of the wire here. I've cut away two of the wires that go into the ink reductor, and there's the resistance coming back now that I've connected to one of the two wires that I've cut away. So more and more we're isolating where this resistance is. And at this point, I think the ink reductor, at this point in my head, the ink reductor is shot. I'm finished. I'm at the end of the road right now. Right now. Let's double check this thing. So I've separated off this, the one they've got noted as white, and the one they've got noted as purple, although they both look black to me. Purple, you can see it's hard to tell. It looks like it's this coil here with the center tap. So in a way, it has to work like this. I have to find the short either in the bands or in these. It would look like I found it in these. Now I have an opportunity here is to sacrifice a couple bands in order to make sure one band works. The bands on this guy, the D band is the one I'd be most interested in, I think. Let's just see if I can quickly find the bands on here. So 3.6 megacycles to 10, 10 to 26, 30 to 80, and then the big one, 80 to 220. 80 to 220 only depends on those bands. The coils don't mean anything. The coils are supposed to be shorted out when they're not in use. But I guess being shorted out doesn't guarantee they're not touching ground, which is the problem here. They appear to be touching ground. If I'm getting 150 ohms partway through a coil, partway through something, if I measure right across the whole thing, I should get the whole resistance. Let's see what happens if I do that. I should get like 300 or something like that. My meter's upset. 300. Something like that, anyway. How about a 0? How do you get a 0 there? How do you short to something that measures 0 and get 150? This guy, he just won't quit. The two wires I took off. Look at this very carefully. The one wire comes into this coil here, it looks like, and the other wire comes down into this coil. Very hard to see what's actually going on here. Okay, so if we look at the schematic, it's a little bit easier to see maybe. So I'm separating actual coil lead wires. So I'm separating them off of the red band down here. So I separated this wire. No, wait a minute. We're on the capacitor side, and there were two wires going to both bands. So I've separated this wire and because I'm on the switch side of the bands. Holy smokes. Well, coming across on the red band, there is only one connection, and I separated it. Coming across on the yellow band, there's a 22K resistor, which is right there, still connected, and that must be the lead wire I separated. So you see they are going to two different coils. It's going here, the other one's going over here. As far as I know, I don't need any of these coils in the circuit. How come it says the coils were shorted as you go along, but I don't see how they get shorted as you're just turning this. It's not going to short any coils. Oh, wait a minute. Yes, it does. Oh, that's, yes. Well, I can't ground them. There's no ground in here. There's no ground in here. The ground, this is ground here by virtue of the connection to the shield of the cable. The shield of the cable goes to ground. This is a grounded line. Ground is brought up onto the rotating plates here, just by virtue of the structure. Doesn't go anywhere else. So how do you even get a ground fault in here? There's nothing there to ground to. Now look at this. What's happening? It's getting better all the time. What is that meter actually reacting to? You know, the meter's connected to nothing. The meter was connected to nothing. Ooh! What happened there? Did I make measurements of nothing? What happened? Get an open meter lead giving me a reading that's close enough to what I expect. Confirmation bias causing trouble again. What happened there? Okay, let's go back and see. One lead grounded, other lead going to one of the wires. We get a dead short. Is that for sure? Is this meter working? Where am I at here? Meter appears to be okay, except I shouldn't be doing that. Okay, to one of the cut wires. What happened there? What's happening there? Just a short little tip of wire here to clip to, and these clips are funny. Just a very bad connection. There's a little bit of evidence of corrosion around here, and it's possible that this rubber material was exuding something corrosive. Okay, now is that a clip lead thing happening there? Jumping all over the place? Let me try the other end of the other cut wire. We have the reading. So we can't know how the metal frame goes inside the ink reductor, how exactly they've got it, but it's got to be in there enough to rigidize everything. So the frame is bolted to the ground. Oh, is it? Is it? Didn't I leave that connection off? Just give me a second here. Nope. The connection appears to be done again. Yeah, the connection's in. Okay, that's good. So we have the possibility of the coil touching ground. Hey, what if I take off the ground? I think there's more than one ground. That's why I didn't do that before. There's more than one path back. So okay, so one end of the wires of a coil, I believe is a coil, I get that reading to ground. And I read to the other end of the coil. I get the 0, or near 0. 0.5, 0.4 on there. Yeah, no, that's a stupid thing to do. This is what I want to do. 0.4, 0.5. This is still a loosey-goosey clip lead. This is junk. Get rid of this. Why don't you do it the other way around? No, these jaws, they have twisted the jaws on those. Let's go with another one. Doesn't grab much better. Take the other clip? I did. Okay, checking the situation here. That's not very good. 0.9. That's what we're going to be. 0.9, pretty stable. How about a 0? Okay, we're cooking now. What was that again? The last minute it went off 0. 0.8. This is just a hopeless situation here. Okay, one lead wire. This clip is useless too. 121. The other lead wire. Hey, now we're getting somewhere. 121 ohms on both lead wires. Okay, there's 121 on one lead wire. 121, just about exactly the same on the other lead wire, and now between the two lead wires, what is the resistance of the coil that we're checking? Well, it's very low. So it looks like a low resistance coil. You can see the 121 now ohm fault in either direction. Is that coil isolated? Is that just a coil and two leads sticking out and nothing more is going on with it? It's really, really tricky. So I think this is one lead going into this coil. This doesn't make sense to me unless they positioned two of these coils somewhere else in this ink reductor and one coil placed up on top. Where are the other two coils? There's 3 coils. There's 4 if you want to count that. That big guy is this big guy here. So you have one coil sitting up here. What about the other 2 coils? Well, what kind of diagram might reveal it? Well, for crying out loud. This isn't a coil. What is that? You know what this reminds me of? A big power transformer with a tank of oil sitting up on top. Cooling oil. What it reminds me of. A big transformer. Well, it's pretty mysterious because there's definitely a coil wire in there. I'm not mistaken about that. There's another structural piece here. There's a couple structural pieces we can see. Let me switch cameras again. Come on. remote control. So what I'm seeing right here looks like a lead going over. Come on, camera. Phooey. Just bear with me 1 second here. I'm going to take direct control over the focus feature of that camera. Okay, now it won't do anything funny. So there's a lead wire that I've been trying to clip to. And the other one's down there, sticking out. Those two lead wires were connected to these two terminals. You can see clearly one terminal is just hanging there, waiting to get connected to the switch. The other terminal's on the switch because it's always in contact, but the switch is contacting nothing on the back side. Nothing. Ooh, wait a minute. No, I'm looking with my own eyes. There's absolutely nothing on the back side of this wafer. Nothing going anywhere there. So there you can see the one, what looks like a copper turn. In fact, that would be the last copper turn. And you can see the copper band where I've just distorted it there. There wasn't a short there before, there soon will be. Then we can look down and see the lower band. You can see the yellow paint on it now. But it's going to be just as gooped up in here. So is that simply a lead? A lead from what? Or is that a coil that's used normally, and then when you get down to like band D, that coil is no longer used. Instead, these bands are enough. What would that coil be doing there? I'm sure I'm not mistaken about the this big bulb here, and there's another one on the other leg, is the coil that generates the bias current in there. These are that's one of the connections that I'm afraid to try to separate. Looks like it might be easier done down there. Could it be that the varying resistances that I measure here, 172, 164, 134, different things like that, are variations in the number of turns getting involved in the problem? Just waiting for something to jump out at me here. Wires look a little bit melted, you know, the insulation on them, but it's probably from soldering. But okay, so there we're looking right at the ends of the coils, and you can practically see the wire I separated away goes into these coils on the side, not on the top. The top is up here. Should be no wires going to it. I was going to talk about the structure too. There's another piece of it. This piece right here. So there's a similar similar thing over here, like a spot where you drop this coil in there, and then those pieces are coming up and picking up the magnetism and transmitting it down in there. I don't think so. I don't know. I don't know what they are up to here. What is my next step? So all this stuff is connected together. Hard time figuring out which one is the short. You can free it off the capacitor here with a bit of work. Ultimately, I can rip this copper right off the top of that thing if I have to. Especially if I just release one side, I can just lift it and just rip it out of there and be easy. Okay, so what's this side look like again? I think I can work that loose. And it looks like it's kind of tacked together. Oh boy. Okay. Let's heat up the soldering iron again. This might require a bit of brutality. Let's make sure we've got the meter going the whole time. Show me a good ground spot. Okay. And we'll pick off, where am I going to be poking? We'll pick off over here. And what do we get now? Open circuit. Wait a minute. Wait one cotton pick a minute here. This is open? Yes, yeah. Whoa, wait a minute there. If you're proving the short is in the coil, then you should find that the short is not in these bands. And that's what I just discovered. Duh. Let's hook up again. Nothing going on with those bands at all. Okay, lay off on that. So now we know it's not the bands, it's not the capacitor. The only thing that's left is this coil. Okay. Chances of clearing the fault in the coil is so small, unless it's right at the lead here, which I would be stunned if it is, because it's so stable and I have played around with this thing so much. Fault is deeper inside. I would have to guess that something in here has come in contact with the iron. We still haven't proven it completely. Let me release the ground. I think there's other grounds, but maybe not. I'll release the ground wire under here. See if that disappears. So this would be the connection between the grounding of this circuit, which is built on a fiber board, and the regular chassis. I'm going to remove that. There could be other grounds, but how's the meter doing there? Okay, special screwdriver. And off it comes. More grounds in place here. There's some. Oh, is it still touching? No. Did it change? Let me hook it up with my finger here. So I went to 153, and if I take the ground off, it goes back to 155, 156. Put it back on. So it's finding another ground route. I think they're shielded wire coming up into this circuit. With a is it worth nailing it right down at this point? I think so. So here's that. Oh, for crying out loud! I'm gonna lose that. And I disconnected these capacitors too. So here's a shielded wire. You can't see me shielding here. Underneath the shield for that wire, oh, I can see it there. Oh, that's the wire I just disconnected. Huh. So that shielded wire is carrying a ground back. Is there another ground in here? As there must be to get that. You can't get that without some other ground path. That's pretty tricky to spot. What other ground path? There's another shielded wire here, but the shield is cut up here. It doesn't connect. You have this shaft banging into the... But this shaft... Well... What's going on with that shaft? Okay, we'll take the ground off here and we'll just stick it on the shaft. Okay, shaft is grounded. Look, my battery indicator came on there. Hey, what happened? Wrong shaft. Shaft is grounded. These parts are not. Oh. Well, this one's not. It's just a part of the structure of the switch. Why is this one? Why is that one grounded? Well, it's screwed into this plate. Why isn't this one? I have the right thing. What goes on here? The metal shaft from here to here is not continuous? How can that be? Huh. But the other one is continuous. So is there a problem with that? Don't see it. This would be a solid ground here anyway. It wouldn't give us the reading. Up in here. Let me put the clip back on. Yeah, I'm really chasing crazy stuff right now. But I just have the feeling that craziness is what's happening here. Two bands come over, connect the wires that I have cut. Those wires go to, let's look at it again. Yeah, this diagram's a little hard to trace. One purple wire, well, it's got the colors, so maybe I can find the colors. I mean, you'd have to think that this wire has to be the end of this lower coil, and this lower coil is the center tapped one. What's it showing there? They're showing a wire. See dotted lines? Dotted lines. We're looking up from below. So, you know what, this, oh, that's part of the band. That's what we're seeing. We're seeing the part of the band. That's what we're seeing. Picture of the band. Yeah. The lower band. That's all that is. So I've cut this wire, which goes to the end of this coil, and this other wire, which goes to the end of a different coil. But these coils are connected together in they're connected together quite solidly. Connection. So when I look at the wires, and I can look at the end here, and I can see the coils, and I can actually see the wires going to the coils. These wires I cut go to these wires I cut to one end. Let's see, the one end of this coil, of the center tap coil. Oh yeah, the colors are written. The colors are written. Yeah, but they didn't write them in here. Oh, they did write them in here. Green, orange, white, blue, and brown. So those are the... Why are they telling me the colors of these? Blue and brown, because these are coming out and they're connected. When this thing's built, they're not all connected. The connections are actually external. Somehow made, I don't know. That's my guess. What am I trying to do? I'm trying to figure out which coil is which and where these two wires I cut go. One appears to go, one is definitely this wire. Definitely into this first coil. There's 3 coils here. When I look at the structure, well, three coils, but don't be fooled now. 3 not on here. 3 coils. How are they arranged again? In here. Here. It's 3 coils on the side. 1, 2, 3. So all 3 coils are on the side of this thing. But they look like 2 coils when you look at the end. That's exactly what I see. Still leaves a real mystery as to what this top piece is. So it would be easy if both these cut wires went back to one coil. I'd say, well, that's the coil with the fault in it. Cut them free, abandon them on the basis that the unit says it shorts them out anyway. Of course, they wouldn't be shorted out, would they? They'd be open, so they might stuff might happen. I don't know. Open? I don't know. I don't think so. So they leave the wires open, reconnect everything, turn the set on, see if band D works. Band D works because I've lifted the ground off of the bands by separating these, and I'm sacrificing 3 ranges for the sake of achieving 1. But those other 3 ranges aren't so interesting to me. Okay, that's an approach. Yeah, I got to put the whole thing back together, and then give that a go. Oh my gosh. Look at how much time I'm putting into this thing. Yikes. You too. Hey, thanks so much for watching this. Okay, so I'm readying this for operation, and I thought, hey, why don't I just, originally I found this problem up here by measuring right here and getting 164 to ground. You see what's on that meter? That's what's there now. What? but I cut away the coil wires from down here. And look at this more closely, I kind of was aware of this. One lead I cut is this one right here. The other lead I cut, well, it's probably this one, maybe this one, maybe this one. I don't know. So it turns out the short is still there because I haven't isolated these, I think, because I haven't isolated all these coils. I need to. It's a really weird deal because when you turn the switch all the way around, all these are separated and they're connected to nothing. Except this one. This one's still connected all the way down through here. It's just another part of this switch. And you rotate the switch. In the lower bands, you engage this on one of the lower bands. If you're on band D, the switch is down here, you're pumping more. You've shorted this resistor and you're pumping more bias current into the bias coils, into the introductor primary system. Oh my gosh. So what should I do here? Yeah, I'm going to guess that with these coils shorted, they may still be having some kind of influence in themselves. That if I were to isolate them all away, then this unit's not going to work because it expects them to all be there and be shorted amongst themselves. But there's a short in one of these. I think I just got to cut away these wires, and what are you left with? 22K resistor. How do you short these coils and not just have a short coming through here? That's a good question. So some things I got to study. I think what's happening though is the coils go out of the picture. 22 feeds down here, and then the bands do the are the primary from there. And this is nothing. This becomes nothing. I could isolate this all away and everything would work on band D. I think. Okay, so a little bluebird flew in my ear and said, why don't you isolate the frame of the introductor away from the rest of this guy? The introductor is screwed into the bottom of the capacitor here. So I am going to do that. Now, that means the introductor might be floppy, but let's do it. Now these two screws I'm removing, one of them has the ground strap right underneath it. So what I'll do is I'll put the ground strap. I'll ground the capacitor with a clip lead to compensate for the fact that that's if I want to operate it this way. That's why I'm actually thinking one step ahead here, that maybe this will break the problem. Well, I can have all those coils hooked up again, even if there is a short to the frame. What would it matter? The frame is no longer grounded. Okay, so we'll pull the ground strap away. We'll use a clip lead to ground capacitor frame to the to here. This is a good spot right there. Gone. So that's proving that if you unground the frame, I'm going to clip this right on the frame of the introductor. Wow, okay, so this is very, very, very strong proof that there's a short to the frame of the introductor, but this introduces another option here. What if I simply don't ground the frame? If I leave the frame floating, which is definitely a problem of a sort, will this thing come back to life? even with the coils. Even with the coils connected. Now right now I've got coils disconnected, but if I go to band D, what would it matter? What would it matter? And now we're checking the resistance. It's right at the key spot here. Fantastic. Ready to operate. Just stick a couple tubes in. Any old tubes will do, I bet, at this point. Oh yeah. Disconnect everything. So I'm going to clean up my bench here and get this ready because I just got too much stuff kind of littered all over the place now, and I don't like it. So I'm going to take a moment, clean her up, and we'll see if we can operate it. Okay, I think I'm ready to give it a go here. So because I removed the ground connection onto the frame of the ink reductor, I've had to make alternate grounds for the rest of the circuit. So you see one clip lead here grounding the capacitor frame, and this other white clip lead is going underneath to grab onto the shield braid on a shielded wire that's leaving here. With the shield disconnected, it's not grounded, so I've clipped it with this. So hopefully everything is normal except the frame of the ink reductor is no longer grounded. That's the only change here. Now I got my ohm meter ready to make the key test. The key test is at the end of this coil right here. This is where you always got 100 and something ohms, but look at that. And just how much is there? Let's take a look. How much is there? It's completely open now. So that's a very good sign. And if there's two shorts into the ink reductor frame, then this may be just too bad. That would be too bad. But I'm going to guess there's only one short into the frame. Being an oscillator, you know, it needs all of its ducts lined up nicely to operate, and maybe with the ink reductor frame not grounded, that's a duct not lined up. Okay, turning on my FM radio, sticking the output lead here. Just like that. I like it even better. Put it like that. Yeah, I didn't clean everything up here. Too excited to give this guy a go. Okay, I've done lots of things here. We certainly need to start with the dim bulbs in the circuit, that's for sure. It's my normal practice anyway. Oh, so is that where the stick went? Everything ready? Everybody ready? Front panel settings. So we're on band D to start, up around 100 megahertz. Fine attenuator in the middle, X1 on the big attenuator, and the marker amp is off. We are ready to try it. Okay, this is proof here of something. There we go. Everybody stand back just a wee bit here, okay? Stand back. Applying power. Watching those dim bulbs. Okay, that's the proper behavior on the dim bulbs. I'll let it come up. It's going to be low voltage here eventually. Oh, maybe not, because I've dropped some of the current draw on this. That's an interesting thing. 106, 104 going down because it's starting to draw more current. 94, it's going way down. So we're going to flip it onto full power here. No sparks flying. Check the wattage. It's supposed to be 50. 50. It's supposed to be 50. It's sitting right on 50. Well, actually, it's a touch. It's sinking rapidly. What happened there? Oh, it just went back up. What's happening here? It's going up. It's going up. What strange thing is going on here? It's up to 60 watts now. What could cause that? Oh my gosh, don't start me on another one here. So you have 117 volts on it. Okay, let's tune it. This is the moment of truth. Quiet that radio. Hey! Well, it didn't quiet it. We're in business. I can't believe it. Okay, so sweep width control was up. Sweep width control's down. It's right around 100. The hum, well, we can deal with that kind of stuff. I can deal with that. This is a really good time to stop and stop it, eat lunch, and be happy. That's good. Okay, something's happening here. Not sure what, but I think it qualifies for a thumbs up. Oh my gosh, what a journey this has been. If I just, so I took one screw out that was holding the ink reductor frame. If I just taken the other screw out a long time ago, we would have gotten a lot farther along. But it is what it is. Great. Okay, so next thing will be to explore the operation of this. Try to get it to operate the way it's supposed to operate. That's just as challenging, more challenging really, than what I just went through. And hopefully not. What am I saying? Don't say that. Go and have a good afternoon. So thanks a lot for watching, and tomorrow I'll get myself back in trouble. That's what I'll probably do. See ya.